All right, guys, here we are. It's Wednesday, and we're looking at measure of center, IQR, and Boxplots. That's a lot. So let's go ahead and jump in. First of all, the measures of center that we do use are mean, median, and mode, but not so much the mode, because while there may be questions about who does more often, or who does what more often, or whatever, typically we want the mean, which is the arithmetic average, the median, which is the middle value, way more so than we want the mode, because there just simply can be more than one of them. You have a page in your packet. I don't know the page number off the top of my head, but it's before these notes that we're going to do today for why use a box plot. And if you're not sure about all of the finer points with the mean, median, and mode, you can look those up. But again, your mean is just your arithmetic average. Your median is the central value of ordered data. And your mode are those values that occur the most often, or the value. But this is actually kind of important when you look at all three, because for a bell-shaped distribution, it turns out your mean, median, and mode are the same. And we're talking about a perfect bell. So your median would cut this right in half, right? So that makes sense. This is the biggest frequency because your y-axis is frequency. So that would be your mode, and it would coincide with your median. And it turns out that if you average everything in here, that will give you your mean too. So a symmetric distribution will show these three things in coincidence. However, if you start looking at skewed distributions, then things will happen. The mode will stay at the peak, wherever that peak happens to be, because that's the highest frequency, and it's the same over here. Your median might get pulled a little off of here. So in the direction of the skew, but it's your mean that is really affected by the skew. So your mean is not resistant to these outliers here. So if you're averaging a 70 for 3 or 4 quizzes and suddenly you make 100, your average is going to go way up. If you're averaging a 70 for 3 or 4 quizzes and you get a 0, then your average is going to go down. In this case, it's going down. All right. So that's what happens. The mean does migrate toward the skew. It does it here, and it does it here. So it's going to set up some interesting relationships, because if your mean is less than your median, then you're skewed to the left. If your mean is greater than your median, and you remember this is 0 and it just goes on up, so your mean is greater than your median, then that shows that you're skewed to the right. So remember, scores on a criterion reference test like STAR is skewed to the right. So typically the average is being pulled down by the kids who don't score very well. And so the median might be a better measure. Here, the incomes for the US, all the rich people are moving the average higher. The median is more resistant to that. You throw it at another rich person, it's not going to move very much. So if the median is bigger than the mean, then you've got skewed to the right. Okay, so remember, your mean is just your arithmetic average, and along with that, your standard deviation is used to describe center and spread of a distribution when it's symmetric. So this is the formula for it. So x bar is your sample average. That is just the sum of all of your x's. Remember, this is a sigma notation. It means add them up. So add up all your x's and adjust by however many you've got. So that's what it is, total over n. So the formula says that to find the mean, we add up all the values of the variable and divide by the number of data values. And then sigma is just shorthand for add them up. So that shows up quite a bit in statistics. Also, your mean turns out to be sort of a balance point in your data. So wherever your mean is, if you can picture like this, like a fulcrum for a seesaw, then this will balance it out to where it can sit flat without tipping this way or this way. So that's what your mean does. It feels like the center because it is the point where the histogram balances. All right, we did this in class. Just so you know the answer, 5 policemen are spread out on a highway. 1 each is located at mile marker 12, 22, 25, 37, and 55. To the nearest whole number mile marker, where should they all travel so that the combined distance is the smallest? It would be the median. They would all head for who's ever at mile marker 25. Now, if you throw a 6th policeman here and throw an 80 at the end, what's going to happen is it'll still be the median, but it'll now be the average between 25 and 37. Actually, what is the most impressive thing and most interesting thing is that if you pick 25, it'll work. If you pick 37, it'll work. So when you have like an even number data set and your median is somewhere in the middle, it's actually anywhere from the 2 numbers on either side, from one to the other, because it's just self-adjusting. As you go further from 25, then these people travel less, but these people travel exactly more. So we just average the 2 just because it's convenient. But really, in an even number data set, yeah, it's going to be anywhere from this number to this number on either side of the middle. Don't actually answer questions that way. Just average the 2 like we've always done, and we're going to be fine. So, when to use your mean or median? Now, we just got to get the background right. So, a measure is said to be resistant if it is not very sensitive to the influence of extreme observations. So, that's your median. Your median considers only the order of values. It is resistant to values that are extraordinarily large or small. Also, it is produced from at most 2 data values. So it's not like the mean, which is made up of a little bit of all the data. So if you throw in something weird, that gets mixed in. The median is at most produced from 2 data values. So your mean is non-resistant. Extreme values, say outliers, can significantly change the mean of a distribution because all the data is used to produce the measure. So if you throw in something really big, it's going to pull that average up toward that big value. If you throw something unusually small, it'll pull the average down toward that. So when you have a symmetric distribution, the mean and the standard deviation are great because there's nothing to move it. If you have a skewed distribution with with outliers, pick the median and the IQR for measure of spread. So we've got 2 new things that you're not used to. Standard deviation, you've probably heard of that before. IQR, not so much, but it is a measure of spread. We're about to learn about it in a few minutes. But that goes along with your median. So median is for skewed distributions, and for symmetric ones, your mean is going to be good for it, along with standard deviation. Don't say mean and IQR, and don't say median and standard deviation. Those 2 aren't related to each other. So what about that IQR? That is your interquartile range, and IQR is fine. It lets us ignore extreme values and concentrate on the middle of the data. So really, it's a measure of the middle half of your data from high to low. It's sort of like range, except it's interquartile range. So it's a measure of spread which goes along with the median, because the median is actually within your IQR. And to find your IQR, we need to know what the quartiles are. So let's investigate those. So if you rank order your data and you go from least to greatest and then chop it into quarters, those are going to be quartiles. They divide your data into 4 equal sections after the numbers are ordered. So actually, let's look at it from this perspective. Your median is your 50th percentile, that's the middle. So if you take the values to the left of that, and then you find the median of just those values of the lower half, that'll give you Q1. That sits at your 25th percentile. Then you have your 50th percentile, and if you take the upper half and find the median of that, that'll give you Q3, which is a division at your 75th percentile. And so Q1, median, and Q3 are going to be the borders of the middle half of the data. That's Q1 and Q3. So your interquartile range contains the middle half of your data, that's Q3 minus Q1, and it gives you a number, and that's a measure of spread. And it's a lot better than regular range. So again, median is the just the middle of your data set. Q1 is the middle of your lower half after you've split it with the median. Q3 is the median of your upper half after you've split by your median. And so your quartiles are Q1 and Q3. To get your interquartile range, it's Q3 minus Q1, and that's going to end up being the middle 50% of your data. Now, a quick way to find this is a 5-number summary, and I'll show that on your calculator. When you generate it, it'll give you the maximum value, the Q3 value, the median, the Q1 value, and then the minimum. There's 5 numbers that'll completely describe a data set. And keep in mind that you can actually have a minimum and a Q1 that are the same number. Like, a lot of these numbers can be the same, so when they show up in a graph, they'll look funny, but it's okay. Now, a box plot is a graphical display of a 5-number summary. It's pretty good for comparing groups because you can put more box plots than just one into a graph and compare them. They are really good at pointing out outliers. In fact, I'll show you a couple of ways to find them. They will not show you shape. They won't show you shape. They will show you skew, but they will not show you shape. All right, to calculate outliers, the official way of doing it, first of all, these are values that are extreme and they're outside the overall pattern of your data. So any value that is more extreme than 1.5 times your IQR number is considered to be an outlier. So if you do 1.5 times your IQR and then add it on to Q3, anything beyond that is an outlier. If you do 1.5 times your IQR and subtract it from Q1, then any number below that is considered a lower outlier. And there are mathematical arguments for why this formula is good. I've read them. I don't recall them off the top of my head, but just go with it. So for a modified box plot, and you'll see when we actually do these things, your new low end is Q1 minus 1.5 times the IQR, and the new high end is Q3 plus 1.5 times the IQR. So let's do some examples to see the process. And for homework, there are some problems after the examples for why use a box plot, but let's go for it. So let's get out of here and let's call up this guy. All right, so this is the page in your packet that says why use a box plot, and you can read the first thing. It's an alternative to a histogram, a dot plot, and a stem and leaf plot. It really doesn't follow the area model. It's easy to make, and it's convenient, a convenient way to handle finding outliers. In addition, the construction of it does not involve subjective judgment like a histogram. So two individuals should construct the same box plot for a given set of data, which is not necessarily true of a histogram. There's a lot of ways to draw a histogram, but only one way to draw a box plot. Okay? All right, so dot plots and stem plots retain the identity of the individual observations, but not a box plot. All right, so let's start out with the first one. Okay, Consumer Reports did a study of ice cream bars in their August 1989 issue. 22 bars having a taste test rating of at least fair were listed, and calories per bar were included. So we're looking at calories. Calories can vary quite a bit, partly because the bars are not of uniform size. Just how many calories should an ice cream bar contain? All right, so 5-number summary for the calories, and we'll do the check for outliers. So let's go ahead and go to your calculator, and I'll do this first one with you. So I set this up, and here are the calories, and this is the second one. We're only going to do the calories. And I'm just going to go ahead and get the 5-number summary for calories. I put them all in off of the paper. And what I'm going to do is just quit out of here, go to the home screen, and I'm going to go to a calculator page. So this is the calculator page so that they're linked. And I'm going to do a 1 var stats, one single variable stat. That'll be under, ready? Menu, statistics, stat calculations, and 1 variable stats right here. I'm only using that one list, and my X list is going to be the calories. Pounds would be for a different one. Keep them at a frequency of 1, leave everything else the same, so tab down to OK. And you get just a wealth of things. First of all, you get X bar, which is your arithmetic average. That's the mean. Don't worry about this, don't worry about this. This is your standard deviation. We'll talk about that later. We have 22 values, that's N. And here is your 5-number summary. So your minimum is 111, your Q1 is 182, median is 209.5, Q3 is 319, and the max is 439. So there's your 5 numbers in your 5-number summary. So let's record those. Okay, so here is your 5-number summary. I'll just put it right next to here. So 111 and 182. Hang on, let me get my pen the way I'm comfortable with it. So 182, and let's see, that was 221.5 and 319, and the maximum was 439. So there it is. There's your 5-number summary. This is your min, this is Q1, this is your median, this is your Q3, and this is your max. So if we're going to do a search for outliers, let's figure out your IQR. So 319 minus 182, 319 minus 182 is going to equal 137. So that is your IQR. Q3 minus Q1. All right, that's your IQR. So let's go ahead and write that over here. So your IQR equals 137. And we'll start looking for upper outliers. So we'll do your Q3, that's 319 plus 1.5 times 137. And that will give you 524.5. All right, your biggest data value is 439. This is beyond it, so you have no upper outliers here, none. So now let's go ahead and do, let's see, that'll be Q1, so that's 182. And this time we'll subtract 1.5 times your IQR, and that will give you 23.5. So there are no lower outliers because this is lower than this, right? So you don't have any values that are smaller than 23.5, and so we have no outliers. All right, so we checked for them. We didn't find any. So what I'm going to do now is just pause the video real quickly, and I'm going to draw the box plot for you. All right, I'm back. So I spared you having to live through me drawing this thing because it looked kind of bad at first. All right, so all I did was, you see how I've got my numbers here, 111, 182, 221.5, 319, and 439. So I needed to go around 100, and I don't think I put that quite in the right spot, but that should be at 111. And then this is at 182, and this is 221.5 roughly. And then over here, this is 319 roughly, and this is 439. So draw 1, 2, 3. This is acting strange. So 1, 2, 3, 4, 5 of those lines that match up to your 5-number summary. And so this is your minimum, Q1, median, Q3, max. And remember that, from here to here is 25%. And this is 25%. And this is 25%. And this is 25%. Right? You don't put that there. I'm just showing you this. In fact, I'll get rid of all of them. Dum, 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 dum. Stop it. Dum, 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 dum. Get rid of them all. And then you just connect the middle 3 with a box. And that represents where your IQR is. I set up the scale based on my 5-number summary. I labeled it calories. And the only thing that it needs is a title. So I'm just going to call it calories in ice cream bars. And that's it. There's your box plot. It doesn't show shape, but it is a little bit skewed to the right. A little bit. All right? Yeah. So there it is. Let's go ahead and do the next one, and then we'll be done. Now, this particular one, I am not going to go through all the calculator stuff, but I'll jot down what the 5-number summary is. So this would have a minimum of 121, and then a Q1 of 130.5. This is doing the 5-number, the 1-var stats and getting the 5-number summary. So 136 is the median, and 147.5. And 179 is your max. Now I'm thinking we will probably see an upper outlier here because this is pretty far removed from here. Now your IQR, let's go with that. So your IQR, remember that's Q3 minus Q1. So that'll give you 147.5 minus 130.5. That's going to equal 17. So we'll seek the outliers. Let's do the upper. So Q3 is 147.5. Get that point in there. Plus 1.5 times 17. And that will give you 173. All right, I'm getting a call. So let's pause for a second. All right, guys, sorry about that interruption. So I got this value to check for upper outliers, and it is less than this value here that's actually in your 5-number summary. There may be more. So let's see, looking over this data set, here's 179. Are there any other values that are at or above 173? I don't see any. So this is one upper outlier. Write that real quick. And then we'll check the other side. So we'll grab the Q1. So that's 130.5 minus 1.5 times 17. And if you do that math, you should get 105. And this is not below that. So when we go to graph it, the next lowest number is 169. So that's where our maximum, this is going to go, and then we're just going to put a dot beyond that. So I'm going to go ahead and pause this and spare you having to watch me draw this over and over, and then we'll wrap. Okay, so I drew it all out, and so this is how it comes out. I only scaled from 120 to 180. That kind of contained everything. Here's the label, here's the title, and yeah, so here's your minimum, Q1, median, Q3, and this is the modified max. Remember, the outlier was 179, and you represent that with a dot, so you got to pull into the next number, which is 169. And so there it is. And I think that's pretty much it. So try those problems that come after this, and we will pick this up, I guess, with new material on Friday because we have a quiz on Thursday. Bye.